Welcome back, class. Hopefully you're well and healthy and your family's taking care of themselves as well. Um, this is week three, part one, so we're going to be going through a video here to solve equations again. I know that's been our topic the last couple weeks here, but I still want to do these review activities where you can kind of review your skills. Last week we did one and two step equations. This week we're going to do equations where there's more than one or two steps, depending on how you look at it, but there's variables on both sides of the equation. That's the big thing. We're still solving equations, but with variables on both sides. That's what I want to kind of focus on here. Remember, the definition of an equation, they contain equal signs. That's why we use this rule called inverse operations, SADMAC, where we subtract and add first things across, or just items in general. Then you multiply and divide, then do exponents in parentheses. But again, our focus today are equations that have variables on both sides, letters on both sides. So you're going to have to combine like terms. I got about 4 problems picked out here, and then I'm going to submit a Google form to you where you can try out some problems on your own this week, and then obviously later in the week I'll throw out different activities and eventually go through the answers of the Google form on Thursday or Friday. All right, let's jump right in. First one, we got to solve the equation. We're looking like we're trying to solve for r's. This is the first out of 4 problems here. We have r's on both sides. The first step that I always do is always move things around. It's technically adding and subtracting because this is still the order that I'm going through. But what I'm doing is I'm adding and subtracting things to both sides. Like when I bring this 6r over, it's going to become a negative. I'm going to subtract 6r over. Now why I'm doing that is because I'm technically subtracting 6r from both sides. So the 6r's cancel out on the right side. On the left side, 7r minus 6r, that makes 1r, because you can actually subtract the numbers. Now, if you want to get rid of the 1, you can, but every variable always has 1 in front of it. I'm just going to leave it. Now, at the same time, I'm going to move the 13 to the other side, and I'm going to also do the same thing. They're adding 13, I'm going to subtract 13 across. Now, the reason why is because if I subtract 13 from both sides, these cancel out. That's why I'm doing that number. I want to move them to the other side. I want to move the variables to the left, the whole numbers to the right side. That's kind of what I'm doing. How I think of it is I just drag things. So if I drag it across, it becomes the opposite. When I go across the equal sign, I should say. So if I drag that 13 across, it's subtracting. So negative 4, and we're going to subtract 13. So negative 4, and we're subtracting 13. So if you typed it in a calculator, you should get negative 17 on the other side. Now the last step, if you got to get rid of the number that's in front of r, so you divide by 1, divide by 1. It's always multiplying or dividing last. Those ones cancel out, so you have to put the r. And then the other side, negative 17 divided by 1 is negative 17. Now technically you didn't need to divide by 1. 1 kind of just goes away and you're just left with r equals negative 17. But if there was a number there, that's what you'd have to do. All right, let's jump right in. Let's take a look at the next one here. So my second problem here out of the 4 that I kind of picked out. So in this one, it's going to take me more steps. So I need to get rid of this parenthesis first. So this one might take actually a few steps. So I'm going to distribute the 2 through this parenthesis. So if you distribute, you have to multiply it. I'm going to do that first. 2 times the 4, that's 8x. 2 times the 3, that's a negative 6. All right. So now this problem is just like the last one we did. It just required one more step. So I'm going to move the x's over, so I'm going to bring this x across. When I do that, I'm going to subtract the 2x over because I want to get rid of it. And then I'm going to bring this 6 across, and I'm going to add the 6 over because that's the opposite, right? I'm always doing opposites to both sides of the equation. That way, the items drop out. So if I subtract the 2x across, it's because I'm subtracting 2x from both sides. That way, this side, the 2x's cancel out. I'm adding the 6 to both sides so that 6's cancel over here. Remember, variables to the left, numbers to the right. So this ends up being 8 minus 2 is 6x's. I just subtract the leading numbers in front of them. They're called leading coefficients. And then on the other side, 6 plus 12 is 18. That's the major step there. Now, we're not done yet because, again, this is the order that I'm going in. SADMAP. I've just added and subtracted first. Now I'm multiplying and dividing next. So I'm going to divide by the 6 because that's the opposite. The 6's will cancel, and 18 divided by 6 is 3. And there's your answer. Now, some people like to guess at numbers and just plug in numbers to both sides, but I think it's easier if you just follow the rules. You don't have to like guess at it. It works out every time. Now, if you're not sure, just plug the number back into the original problem, see if both sides balance. That's what you could have done the last one as well. Let's jump to our second to last problem here. So this one has a fraction. So since this one has a fraction, what you want to do is you want to multiply everything by the bottom number. That way it gets rid of the fraction. So I'm going to multiply everything by 3. So multiplying everything on this problem by 3. So 3 times the 2 is 6y. We have the minus sign. 3 times 8 is 24. We have the equal sign. When we multiply 3 on the y, the 3's will cancel that out, and we're left with a 1y sitting there. Because top and bottom cancel out, so we're left with the 1 and the y. And then on the other side, we have the plus, and then 7 times 3, so we have to multiply by 3 there, that is 21. Again, this is probably the goofiest part, is where you multiply by 3, it cancels out that fraction. That's the reason why we chose to multiply by 3, so that it will cancel that out. Okay. So hopefully that made sense. So on your problem, you have to figure out what their denominator is. All right, so now I'm at this, I'm at the stage I'm at. Now this is just a normal problem. I'm going to, move the 1y over, subtract the 1y across. Move the 24 across. I'll have to add it to the other side because that's the opposite. That way, when I draw the line here, the 24 is gone here. I moved over. The 1y is gone here because I moved it over. So I have 6y minus 1y. That's 5y's. On the other side, 21 plus 24, that's 45. On the other side, when I add them. Again, I'm doing opposites, that's why I'm doing this. So again, and subtract first, multiply and divide, and then exponents in parentheses. So I know that it seems weird, like, where you went out of order, you multiplied, but I wasn't solving yet. I was just rearranging this equation so it looks better, and then I just do my normal math. So I'm still not done. I need to get rid of this 5, so I'm going to divide by 5, divided by 5. The 5's cancel. Leaving with y equals, and 45 divided by 5 is 9. Now again, if you take the 9, plug it into all the y's in the original problem, it would have worked out. Again, how you do that, you take, on the original problem, you take 2 times 9, because that's the part in the front. That's 18 minus 8. And then on the other side, you take 1/3 times 9. 1/3 is like taking 9 times the 1, and then dividing by the 3. That's how it works. And then you add 7 to it. And they should work out to be the same on both sides. Alright, last problem here. This one's significantly easier. Let's switch up the color again. Alright, so we do have a 1 out front of that w. There's a 1. Every variable always has a 1 in front of it. That's just the rule that we have. I'm going to move the 5 across. So when I move the 5, I'm going to subtract the 5w over. When I move the 6 on this case, that is a negative 6. So I'm going to make it a positive 6. That's the opposite. So this 6 is gone, that 5w is gone because they move. Remember, variables to the left, whole numbers to the right. I don't need to multiply by any weird number. There's no fractions on this problem and no parentheses. So 1 minus 5 is negative 4w. That's 1 minus 5. On the other side, I get a positive 16, 10 plus 6. And now the last step is divide by negative 4. And again, I'm dividing because this is a negative 4 times w. That's why I'm choosing to divide. I know some people want to add it and you have to divide it. That way the 4's cancel out. And 16 divided by negative 4 is negative 4 when you divide it. Okay, hopefully that made sense. That was all 4 problems that I kind of picked out for you. Submitted a Google form so you can try out some problems throughout the week. I'll give you the answers on Thursday or Friday this week, and I'll give another topic that you can try out maybe on Tuesday or Wednesday. Take care of yourself, take care of your family, and I hope to see you soon.